Hey there everyone, we're here with some more examples. Here we have some simple derivatives, looking at some pretty basic applications of the derivative rules you've seen so far. Feel free to skip around on this video, and if you need to go to a specific example, I'm just going to do these in order, 1 through 6, so take your time as needed. Here, for this first one, we're looking for d dx of x to the third. Remember, d dx is this derivative notation. Sometimes we don't have functions, sometimes we have expressions we want to take the derivative of, and this is what we'll be using, this d dx. Do note that this d dx is kind of saying, well, the change in this thing, right, the change in the y values in the function itself over the changes in the x. Again, derivatives are the slopes of tangents. This is really talking about a version of a slope. So use that notation to your benefit. Here, in looking for the derivative of x to the third, we're going to apply the power rule just very directly. We're going to bring this 3 to the front. We're going to multiply that by x raised to that same power minus 1. And simplifying that, we just get 3x squared. Applying that rule directly again, the power rule, we're going to find the derivative of this. But do note the 4 is kind of out in front already. So I'm going to do this really step by step. It's not necessary you do this the same way, but I really want to show that this little 4 kind of comes out of the derivative. This is the constant multiple rule. So after that, we can apply our power rule directly and now say 4 times 5x to the fourth, and so in total we get 20x to the fourth. Number 3 is very similar. Again, I'm going to apply all the rules of derivatives we learned so far, just to really show that, yeah, they do work, right? We can use our shortcuts just a little bit, but there's a basis for all of that. So from here, I'm going to pull these constant factors out front. And at this point, I'm actually going to find the derivative of this. d dx of 4 is derivative of a constant number. Derivatives of constant numbers are 0. If you think about constant functions, they are always horizontal lines, and their slope is always, well, 0. From there, I'm just going to simplify a little bit further, apply those power rules, and get something like 6x squared plus 12x. All right. Moving on to number 4. Here we're asked to find the derivative of 3 sine x. Again, I'm applying these properties directly. We're applying the constant multiple here. And now we're taking the derivative of sine x. Hopefully you read in the book or in an activity or exercise that the derivative of sine x is just plain old cosine x. For number 5, we're asked to find the derivative of negative 4 e to the x plus 2x. Again, I'm going to apply all the rules directly. I need negative 4 out of there, d dx e to the x. I did apply the sum rule pretty quickly there, so excuse me for that. Right, derivative of the sum is the sum of the derivatives. And now I factored out the constant multiples, negative 4 and 2. Again, hopefully you have seen that the derivative of e to the x is just plain old e to the x. This is a very unusual situation. This is the only function it happens for. A lot of really interesting properties about it, but we'll talk about that another time. Here, the derivative of just plain old x is, well, 1. There's a lot of different ways of thinking of this. Again, x itself is a line with a slope of 1, so it makes sense that the derivative at any value of x, right, the slope of those tangent lines is just 1. In this case, I can reduce to negative 4 e to the x plus 2. Last but definitely not least, we're asked to find the derivative of 6x to the 1/3. Again, constant multiple rule, apply that. And then we're going to apply our power rule. Now, you may seen our power rule work for whole numbers and even integers. They actually work for pretty much all real numbers. Here we have x to the 1/3 power, and so from there we're just going to apply it directly. I'll show all of these steps as well, where I take the current exponent to the front, and then write x to the 1/3 minus 1. 6 times the third is 2. X to the 1/3 minus 1. Take a second, think about that. -2/3. I hope this video has been helpful. If you have any questions, just let me know. I can only help if you ask.